now?
Yes.
All right.
Yes.
Okay. Okay, so let's not waste any time. Let's proceed with our lecture. Okay, so we have one more subtopic to go, which is the electrolytic cell and its application. Okay, all right. So you have been introduced to electrolytic cell and how the setup of electrolytic cell looks like. Okay, so the components of electrolytic cell. And then we have the comparison between electrolytic and galvanic cell. Okay, and make sure that you know how to differentiate between electrolytic cell and galvanic cell. Okay, and also the similarities of these two cells. Okay, all right. Next will be the factors affecting product of electrolysis. So these are the factors that you have to take into consideration when you perform an electrolysis process. Okay, so the first one will be the standard electrode potential of the competing species. The electrode potential of the species involved in the electrolysis. And then the description of it, the more positive the E0 reduction, the easier the species to be reduced at the cathode. Okay, so these two are very important. Okay, later on you will have to determine who will be discharged at the anode and who will be discharged at the cathode. Okay, so the rule of thumb is to choose based on if the at the cathode ataupun for the reduction. Okay, we are going to choose based on the more positive of the E0 reduction based on SRP again. Okay, so the more positive will be reduced ataupun will be easier to be reduced at the cathode. And as for at the anode, okay, we are going to choose the E0 reduction that is more negative ataupun less positive because it will be easier to be oxidized at the anode. Okay, for example, if we have copper, okay, so we have anode and cathode, right? So cathode, the charge is negative. Okay, whereas anode, the charge of the electrode is positive. Okay, so this is opposite to galvanic cell. All right, the negative charge electrode will attract the positive ion. So kita separate them into two categories, the positive ion and the negative ion. So these are all, as you can see, positive ions, and we have H2O. Okay, all right, so copper 2+, Ag+, and H2O will be attracted to negative electrode. So between these three, we have to choose which one will be discharged. Okay, will be selected at the cathode. So we are going to be based on the values of the E0 reduction based on the SRP table. Okay, so based on this statement here, we are going to choose based on more positive value. Okay, as for the anodes, all the negative ions, they will be attracted to anode. Same goes to H2O. H2O will also be attracted to anode. Okay, right. H2O dia tak necessarily form ions. Okay, dia by nature it is in molecular form, H2O kan. In fact, dia punya separation into H+ dengan OH- tu, dissociation into these two ions are very, very weak. That's why we have Kw. But okay, they still will be attracted to anode and also cathode. Okay, sebab the molecular of the water itself has tendency to be attracted to both positive and negative. Okay, and it is also a polar molecule kan. Remember, water is a polar molecule, so it will be attracted to both anode and cathode. So for anode, we are going to choose based on the more negative the value. Okay, the more negative the value will be discharged at the anode, ataupun less positive value will be chosen. Okay. And then number 2, concentration of ions in electrolyte. So this is the second consideration that you have to be aware of ataupun to consider. Okay, so the more concentrated the ion, the easier it will be discharged at the electrode. Okay, so not only the reduction potential that you have to consider, you need to consider the concentration of the ion itself. And ini consideration yang you kena take note juga. Okay, if it is concentrated, then it will be easier to be discharged at the electrode. Okay, all right, so look at the example that we have here. So we have copper 2 plus and Ag plus. So these two will be attracted to anode. Is it? No, cathode. Okay, cathode. Okay, because it is negatively charged. Cathode is the negative electrode. So these two will be attracted to cathode. So by right, if we are based on the value, okay, the more positive value will be chosen. So by right, we are going to be the Ag plus will be chosen at the cathode. Okay, but itu yang normal condition lah, under standard condition. Okay, Ag ion will be discharged first at the cathode. But however, if the concentration of copper 2 plus is increased, katakanlah we change the concentration, so copper 2 plus is the concentration of copper 2 plus is higher than Ag plus. Okay, and this caused the electrode potential also to increase. Okay, the potential of the copper 2 plus also increase. So at high enough concentration, the electrode potential of the copper 2 plus copper half cell can become more positive than 0.80 volt. So this one initially kalau normal under normal condition, it is less than Ag plus. Tapi kalau the copper 2 plus punya concentration is higher ataupun larger than Ag plus, it can be more than 0.80. Okay, dia boleh lebih tinggi daripada 0.34 and it can be more than 0.80. Then copper 2 plus ion will be discharged instead of Ag plus ion. So those are the things that you have to consider lah. Okay, in terms of dia punya concentration. So you have to take note also, if the difference in the standard electrode potential of the two competing species is too large or species is unstable in water, then concentration is no longer an important factor. Okay, all right, so consider this one. As you can see, the difference between these two reading is not that far. Maksudnya dia taklah jauh sangat. Okay, so therefore we have to consider we have to consider in terms of concentration. Tapi what if katakanlah we have sodium plus and Ag plus. So sodium plus is like the value is very high. Maksudnya sangat apa nama tu, negatif. Okay, dia sangat negatif, and then we have Ag plus. So in that case, even the concentration of sodium plus is higher than Ag plus. Kalau kita nak consider the concentration kan. Tapi ada one thing yang you kena consider juga, dia punya reduction potential. Okay, kalau dia terlampau, beza dia terlampau jauh, even though dia punya concentration is higher, we are not going to consider for that particular ion. We are going to consider for the one that is easily to be reduced. Okay, yang paling senang untuk reduce, walaupun dia punya concentration dia tinggi. Okay, so this if only kalau dia punya two competing species is too large, terlampau beza sangat. Kalau between Ag plus and copper 2 plus, this is not that far. This is like 0.4. Kalau beza dia like 1 point something and above, that one kita tak consider on the concentration at all. Kita just based on the electrode potential. Okay, alright, the reduction potential. That is number 2. Number 3, nature of the electrodes. Okay, so special type of electrode used will influence species to be discharged. Okay, all right, so we have two types of electrodes. Active metal electrode. So active metal electrode means the word active there means it is involved in the electrolysis process. It is involved in the reaction. Okay, all right, so electrolysis of aqueous copper sulfate solution, for example. Okay, so the solution of aqueous copper sulfate is used. So metal copper will is used as the anode, will dissolve and not produce oxygen at anode. Okay, all right, in this case we use copper as the metal and the solution as the anode, metal copper as the anode. So this is active metal. Why? Because the solution used is also copper 2 plus. Okay, so this metal copper will be involved in the electrolysis. Okay, it will be involved in the electrolysis, and then instead of normally water will be discharged. Okay, water will be selected and produce oxygen at the anode. Okay, dioxidize jadi oxygen. Tapi if active metal like copper is used, and then the copper sulfate solution is used as copper sulfate is used as a solution. Okay, so instead of oxygen will be released, will be produced, tapi dia akan pilih copper. Okay, metal copper tu, the anode will dissolve. Okay, we are talking about the electrode tu will be dissolved, will be chosen as the one to be discharged at the anode. Okay, that if we are using active metal electrode. If we are using inert electrode like platinum, like graphite, like carbon, kan? Carbon is known as graphite. Carbon rod being used as anode in the electrolysis of copper sulfate solution, then oxygen gas is involved at the anode. Okay, alright. So ni macam biasalah, kita still need to consider who will be going to the anode, who will be going to the cathode, kan? Kita list out dulu, and then we are going to choose based on the reduction potential based on positive negative value tu. Okay, so normally if we use inert electrode, oxygen will be H2O. Okay, will discharge, ataupun bila dia oxidize, it will produce oxygen. Okay, so kalau pakai copper just now, bukan oxygen yang akan discharge ataupun produce oxygen, it will produce copper metal. Okay, that is number 3. So those are the 3 considerations that you have to take note. Okay, right. So let's have an example of electrolysis process. Okay, let's start with molten salt. Molten means lebu. Okay, garam lebu. So the compound that need to be electrolyzed need to be in liquid form or aqueous form. Okay, why? Because we need the ion to be mobile. Kalau solid form, the ions are locked in places. Maksudnya dia tak boleh bergerak. So when there is no mobility of the ion, so the electricity cannot be flow through ataupun cannot be conducted. Sebab dia tak ada ion yang mobile. Okay, so the compound must be in molten. Molten, if we are referring to salt, okay, dia adalah lebu, maksudnya dia in a form of liquid. Okay, but there is no water in it. If aqueous, then we have water in it. Okay, alright. So we use inert electrode, is either platinum or graphite. So cations are reduced at the cathode to metal element, anion oxidized at the anode to non-metal element. Okay, so electrolysis of molten sodium chloride, single molten ionic compound. That means we use only single ionic compound. We don't mix with other ionic compound. Okay, maksudnya let's say we have sodium chloride, that means we have sodium chloride only in the for the electrolysis. Okay, in the cell. So we can also have a mixture of salt, tapi tu we will look into that later. Okay, alright. So macam biasa kita kena identify anode is the positive electrode. Cathode is negative electrode. So positive will attract the negative ions. Negative will attract the positive ions. So since we are electrolyzing the sodium chloride, so sodium chloride will produce sodium plus and Cl minus. Okay, so Cl minus will be attracted to anodes because they are opposite charge kan. Sodium plus will be attracted to cathode. Okay, and undergoes reduction. Cl minus undergoes oxidation. So how do you write the equation? Okay, for oxidation reaction. For Cl minus, so Cl minus will undergoes oxidation. So Cl minus will form Cl2. Okay, alright. So this is oxidation kan. Bila buang electron, Cl minus remove the 2 electron yang they accept to becoming Cl2 in gas form plus 2 electron. Make sure that you are able to write this the oxidation and reduction state of the ions. Okay, the equation. So this is the half equation for the oxidation. So it produces Cl2. So the product at anode will be the chlorine gas. So you will see if you perform this electrolysis process, you will see ataupun you will observe the bubbles lah. Okay, that indicates the presence of chlorine gas. Whereas for sodium plus, it will be discharged at the cathode. So cathode, it undergoes reaction. So sodium plus will accept the electron and becoming sodium solid. Okay, alright. So the product, the final product that you will be observing at the cathode will be the sodium solid. So you akan nampak lah ada deposition of solid sodium solid. Okay, alright. Keep moving on. Then electrolysis of mixture. Just now we have single. Mana tadi? Single molten ionic compound. This one we have mixture of molten ionic salt. So still molten form. Okay, but this is a combination of salts. Okay, so dia ada competing. Dia berebut lah. Okay, so we need to decide which one will be selected at the anode and which one will be selected at the cathode. So nak based on apa? Based on E0 reduction in SRP. Okay, so the concept will be dia punya idea is based on the E0 reduction. So the cation with the most positive will be reduced at the cathode, and the anion that has the most negative E0 reduction will be oxidized at the anode. So you are going to be based on this one. Okay, all right. Predict the product of electrolysis of a mixture of molten aluminum bromide and magnesium bromide. So liquid in this, kalau you nampak L dekat situ, it represents the molten state of the salt ataupun metal. Okay, so liquid selalunya kita represent untuk water kan, tapi we do have liquid for liquid state for salts and also metal. Okay, alright. So make sure that you know how to write the equation for the dissociation of the salt. Okay, so we have two salts there, AlBr3, MgBr2. So these two will dissociate into Al3 plus and 3Br minus. Make sure it is balanced. Balance tu tak payah cerita. You buat balance equation, mesti kena balance. MgBr2, okay, Mg2 plus and 2Br minus. Okay, anode and cathode. So anode is a positive electrode. Cathode, on the other hand, is the negative electrode. Anode is where the oxidation takes place, whereas cathode is where the reduction takes place. So since we have one negative ion saja, one species of an ion, one species of an ion. Okay, dia tak ada chloride, dia tak ada iodide and so on. We have only bromide ion, so definitely bromide will be attracted at the will be the one that is going to be discharged at the anode. There is no competing reaction. Sebab dia yang attracted and dia juga yang dipilih to be discharged. Okay, for oxidation. So Br minus undergoes oxidation. Dioxidase maksudnya Br minus ni buang elektron, tolak 2 elektron, since we don't normally use minus sign. Okay, kita transfer to the other side, dia jadi 2 elektron. So Br dia akan jadi Br2, bukan jadi Br Dia punya original state is Br2. Common state dia adalah Br2. Same goes to Cl, Cl2. Okay, iodine also iodide. Iodide will form iodine will form, iodide will form I2. Okay, so in order to balance it, to balance this equation, you have to put coefficient of 2, okay, at the front of the ion. Okay, and then a product at anode, so it will produce bromine gas. For cathode, okay, let's look at cathode. So for cathode, we have competing species guys. So we have Al3+ and Mg2+, both will be attracted at the cathode. Tapi which one will be chosen? Which one will be discharged at the cathode? Which one will undergo the reduction? Okay, alright, so macam biasa kita akan based on the value. So kalau based on cathode, the more positive the value, okay, then the higher tendency is to be reduced at the cathode, to be discharged at the cathode. So based on the value, aluminium has more positive value. So that less negative, more positive ataupun less negative. Okay, so is selected because of the more positive value. So macam biasa, this is reduction. Okay guys, this is reduction. So you boleh pakai lah. Ni kebetulan yang sama. Okay, you jangan confuse this one yang dia just nak compare in terms of value saja. Sebab based on SRP kan, all of them are in reduction form. Tapi bila nak buat reaction dekat electrolysis, kita dah tahu dia reduction. That means this is the form lah, which is the same as the SRP yang reduction tu. Betul tak? Tapi kalau oxidation, you have to be careful. Because oxidation is opposite to reduction. Yang dalam SRP reduction, kita perlukan value dia sahaja for comparison. But when you want to write the oxidation reaction, you have to change in the form of oxidation. Okay, so be careful. Okay, so aluminium solid will be discharged. Okay, checkpoint 8. Okay, let's KIV this one first. Okay, let's finish off the subtopic first, and then we will come back to checkpoint. Okay, we will proceed. We will continue with the checkpoint. Habiskan dulu semua. Okay, guys. Okay, so let's hold on to this first. Then just now molten. That means we don't have water in apa nama tu, in the electrolyte. Now, what if we have water in the electrolyte, and it is called aqueous solution? Okay, so for water, that means we have water in it. We have to consider for apa nama tu, water. Okay, because it will also be apa nama tu, attracted to both anode and cathode. Okay. Alright, sebab dia later on it will produce ions H+ and OH-. Alright, so from SRP table you have to consider two things guys tu. Kalau H2O tu, okay, H2O tu dia produce oxygen, okay. Sebab yang produce oxygen tu, kalau dia dekat anode, it will produce oxygen. Dia undergoes oxidation kan. And then the other one, sebab dia H2O, the other one pun H2O. Okay. Alright, the other H2O tu, the one that produce H2. This is kalau dia undergoes reduction. If water yang being selected at the cathode, for example, cathode kan reduction kan. So reduction kita tahu one of the criteria is producing H2. Maksudnya dia akan ada H2. Salah satu kriteria dia lah. Okay, so this then we are going to be using this equation. Okay, reduction for cathode. Tapi kalau katalah water is also being discharged at the anode. Okay, katakanlah dia dipilih juga. So, kalau dekat anode oxidation kan, so dia akan, the product at anode ataupun of oxidation will be oxygen, O2. Okay, dia ada dua equation berbeza, nampak? Even dia punya value pun satu different value. Okay, sini H plus, this is OH minus. So, it's not the same. Okay guys, alright. So katakanlah you perform an electrolysis of water. Okay, there's only water as the electrolyte. Okay, so what will happen is that H2O will be attracted to anode. H2O will also be attracted to cathode. Cumanya produk dia berbeza. See? Produk dia berbeza. Azan, kita stop sekejap ya. Okay. Right. Oops. Okay, alright. So since we only have water in this electrolysis process, okay, so definitely water will be discharged at anode and also cathode. It's just that the final product discharge is different. Kalau at anode, it will produce oxygen gas, see? But if at cathode, okay, it will produce hydrogen gas. But again, you kena be careful, especially for anode oxidation. Reduction is not a problem because dia sama dengan from SRP. These two are from SRP punya table dalam reduction form. See, 2 electron. So this one is yang dekat cathode. Okay, this one sepatutnya dekat anode kan? But anode, this is in reduction form. Maksud nampak tak? Dia accept electron. But for oxidation, in oxidation, you kena apa nama tu? Kena electron tu kena make sure, okay, they stay on the product side. Okay, dia mesti duduk dekat product side. So dia jadi H2O, you buat macam tu dulu. H2O producing O2. Okay, nak balancekan. So sini H2, sini ada satu, ni ada satu oksigen, ni ada dua oksigen kan. So kita tambah dua oksigen and dua at the front of H2O, so it become 2 oxygen. So here we have 2 oxygen, but we don't have H+. We don't have hydrogen on this side. So kita tambah H+. Betul tak? So berapa banyak H+ that we need to add in? 2 times 2, 4. Okay. Alright, so balance kan kosong. So this one kita ada 4. So kita kena tambah elektron dekat belakang. Sebab after all, this is also oxidation. So there you go for your equation. Okay, kena ingat kalau dia oxidation, water will produce oxygen. Kalau reduction, water will produce hydrogen. Okay, cuma oxidation punya part you kena be careful in order to kalau dia suruh buat equation, make sure that you transform the reduction form here into oxidation. Right. Okay, so that is for water. Maksudnya in aqueous solution you have to consider for water as well, not only for the ions. Okay, for the salts, you also need to consider for the water. Okay, so there is a high possibility that water will be discharged. Sebab water punya ni E0 reduction is considered reasonable lah. Okay, so most likely dia boleh dipilih sebagai the one that will be discharged at the anode and also cathode. Okay, cuba tengok contoh. Aqueous solution water soluble salts. Okay, so we dissolve salt in water. Therefore, it will contain cation and ions from salt and also water molecules. Okay, so at the anode, water and anions are competing with each other to be oxidized because anode is positive, kan? Cathode is negatively charged. So H2O will be attracted to positive charge and ion memang negative, it will be attracted to positive electrode. Okay, so for cathode pun sama, H2O will be attracted to the cathode and cation, the positive ions will be attracted to the negative electrode. So dia akan compete, okay, with each other in order to be oxidized and also to be reduced. Hence, for aqueous solution, the product at electrodes depend on which species are selected to be discharged, whether oxidized or reduced. Again, kita akan based on reduction potential. Okay, alright, so at the reduction and also for the reduction and oxidation at the cathode and anode, you need to consider for water. Nak highlightkan lah dekat situ. Okay, you kena ada water juga. You kena consider for water. Water might be discharged at the cathode and also at the anode. Macam mana nak tahu? Based on reduction potential, value dia tu. Okay, alright, so kalau reduce, dia akan produce H2, like I said just now. Kalau oxidation, okay, kalau it is selected for at the anode and to undergo oxidation, it will produce O2. So this is the equation. Okay, accepts, reduce. Elektron dekat belakang sebagai produk will be the oxidation equation. Okay. Okay, contoh, cuba tengok contoh. Electrolysis of potassium sulfate solution using platinum electrode. So platinum is an inert electrode. Okay, alright. So KSO4 sulfate solution, aqueous solution. The word solution means there's water in it. Ada water, so kena consider water. Okay, alright. So we know that the salt will dissociate to produce K plus and SO4 2 minus, the anions and the cation. Okay, and so these are the species that we have in the solution. We have K plus and SO4 2 minus and also water. Okay, untuk water. So kita kena bahagikan, kita kena separate. So anode is positive electrode, cathode is negative electrode, kan? So the negative ion will be attracted to the positive electrode, which is the anode. SO4 2 minus and H2O. Don't forget the H2O. Whereas for cathode, K plus and H2O will be attracted to the negative electrode. And then kita kena pilih based on SRP punya table. We need to we need to have the values of the E0 reduction for each of these species. This is for comparison. Okay, ini dapat daripada SRP. So value dia ini. Okay, kita kalau anode kita akan choose based on the more negative the value. Okay, ataupun the less positive value will be chosen, will be discharged. So siapa yang less positive ataupun siapa yang more negative? Water, see? Based on value ni, water is more negative. Bukan, water has more negative, more negative value. Okay, so water will be selected to be oxidized, not sulfate ion. Okay. Alright, so bila this is for macam nak pilih aja, tapi you kena buat equation untuk for water, oxidation of water. So this is the equation for water. So as you can see, you nampak you produce oxygen gas tu. So product at the anode will be oxygen gas. So you will see ataupun observe the bubble of gas produced at the anode. Whereas cathode, so sama kita kena pilih, okay, since this is at cathode, so kita akan choose the one that has positive value ataupun less negative. So negative 2.92 dengan negative 0.83, mana yang more positive? Water again. Water will be chosen. Water will be discharged. So for kalau reduction punya equation for water, which is sama pula dengan the one from SRP. So as you can see, they produce hydrogen gas. So product at the cathode, you will observe also bubble, okay, tapi hydrogen gas. Ini kena test lah, okay, how to differentiate between these two. Sebab both pun colorless gases. Okay, so basically kita just compare sajalah. Okay, what if it is diluted solution? Diluted aqueous sodium chloride solution using still inert electrode, platinum. Okay, so like previous one just now, you kena list out all the possible species in the solution. So we have sodium plus, chloride ion, and also H2O. Okay, anode is positively charged. This one is negatively charged. Okay. Alright. So we are going to compare the value. Compare value. Okay. Oxidation dia nak negative value kan. The more negative the value ataupun the less positive the value will be discharged. Yeah. More negative. Guru. Okay. So water will be discharged. See, based on the value. Okay. So water will be discharged. So sebab this is at oxidation. This is at anode or oxidation process. Okay, so it will produce oxygen. So this is the equation that you should be writing. Okay, that should be written. So product dia still oxygen gas sebab kita compare. Cathode on the other hand, compare. Okay, kita nak yang more positive. As you can see, sodium punya value is very negative. Very negative. This is very far. I mean, dia punya value tu sangat beza. Besar, large difference. So water will be selected again. Okay, so in this case it will produce H2. So this is the equation. Okay, so H2 gas will be produced. This is diluted. This is concentrated. Okay, all right. Concentrated means we have more ions, less water lah. Okay, all right. So still sodium chloride. Still sodium chloride using platinum electrode. The ions ataupun the species that we have in the solution is still the same, We still have H2O, sodium plus, and chloride ion. It's just that the concentration of Cl minus and sodium plus are now high ataupun larger compared to diluted just now ataupun the normal solution. Okay, the concentration are now higher. Okay, so macam mana? How do we select? Okay, anode oxidation macam biasa, Cl minus and H2O will be attracted. Okay, so kita akan base on this value. Okay, even though water is less negative kan. Tapi since Cl minus punya concentration is higher than water, and as you can see, the difference is not that far. Dia tak jauh sangat beza dia. Okay, therefore Cl minus will be chosen atau will be discharged at the anode. It's selected to be oxidized because the concentration of Cl minus is very high and it will be selected to be oxidized. Repetitive. Okay, alright, so this is the equation of Cl minus being oxidized. Okay, alright, make sure that it is balanced. As you can see, it produces chlorine gas. That will be the product for oxidation at the anode. Okay, let's look at cathode now. Okay, macam biasa sama je attracted, even though, okay, as you can see, okay, the value is very much different. These two value is it has these two value is too far apart ataupun large difference between the two of them. Okay, alright, even though sodium plus the concentration of sodium plus ion is larger, okay, but it will still not be discharged at the cathode. It will not going to be discharged at the cathode. Okay, water will still be discharged at the cathode. Remember, we will go back to this one. Note, kalau dia punya electrode potential space two competing species is too large, okay, walaupun dia concentrated, okay, we are not considering the concentration. We just focus on the competing species sajalah. Okay, we just based on this one. Yeah, this one. So based on this one. Okay, kita just, we can ignore the concentration of K plus, even though it is high. Okay, alright. So the species that has more positive value will be this charge. So the product at the cathode will be hydrogen gas. Okay, done. H2 lah. Okay, H2 hydrogen gas. Let's look at example. An aqueous solution of aqueous, that means we have water, zinc sulfate and nickel sulfate undergoes electrolysis. That means we have a mixture of aqueous solution. Okay, based on reduction potential, what product are expected to be observed at the electrode? Okay, so you have to divide into anode and cathode and then list out all the possible ions or species present in the solution. So we have zinc, okay, we have nickel, both also sulfate and SO4, 2-, and then we also have water. Okay, alright, water dia available on anode, at the anode and also cathode. Okay, alright, so kita asingkan. SO4 2- and water will be attracted to the anode, whereas cathode we have 3 species there. We have nickel 2+, zinc 2+, and H2O. Okay, alright, again macam biasa kita akan select based on the reduction potential. Kalau anode kita akan choose the one that is more electro and the one that has negative value, more negative value ataupun less positive. So this is less positive than 2.01. Okay, therefore water will be discharged. So water kalau undergoes oxidation, it produce O2. Okay, this is the equation. Okay, alright. Cathode on the other hand, kita compare cathode reduction kan. So reduction kita akan choose the one that is more positive, that has more positive value. So between these three, the one that has more positive value is nickel. Okay, so nickel will be, nickel 2+ ion is selected to be reduced because of the more positive inert reduction. So the equation, okay, so this is the reduction equation. As you can see, it produces nickel solid ataupun nickel atom. So you can observe that nickel solid, okay, is deposited at the cathode. Right? The checkpoint there, checkpoint 10. And last but not least, cukup-cukup je time. Okay, electrolytic cell and its application. So this is the application of electrolytic cell. Okay, it can be used. Okay, electrolytic cell can be used to extract the aluminium from bauxite. Bauxite ke bauxite ke from bauxite katalah. Okay, alright. So bauxite is actually a compound that made out of Al2O3. Okay, it has aluminium and oxygen. It's a compound lah. Okay, so how do we extract aluminium from this compound? Okay, alright. So how industry perform this aluminium extraction? Okay, aluminium is actually one of the most abundant metal in the world. However, the price ataupun the cost of aluminium is very expensive. Why is that? Kenapa dia macam tu? Kalau dah dia paling banyak, patutnya dia murah. Okay, it's because of the cost of extraction of aluminium. It's very expensive because we are using electrolysis. Okay, kita nak extract out the aluminium from bauxite. We require electrolysis process. So this electrolysis process uses a lot of electricity. Okay, so that's why dia punya cost mahal lah. Okay, so initially, okay, dia punya plan adalah kita electrolysekan this bauxite. Kita electrolysekan, maksudnya molten lah, initially lah, the plan is to, this is like macam cerita balik lah, okay. Kita cairkan dia, and then kita electrolyse lah, betul tak? Kita cairkan dia, kita melt the bauxite, and then we electrolyse. So we can separate, so aluminium will be moving towards cathode, okay, aluminium 3+ will be moving towards cathode, oxide on the other hand will be moving towards anode and oxidize. Kan, that's the plan, very simple. But one thing yang you kena consider, okay, bila dia jadi molten, you kena cairkan kan, you have to melt the bauxite. Now melt the bauxite, you know what is temperature used to melt bauxite is 2000 and above degrees Celsius. Sangat tinggi. So kalau tinggi pakai temperature tinggi, again, okay, it is costly and very expensive. So, alternative to that, okay, how do we solve this problem? So, industry, okay, they dissolve this aluminium ataupun bauxite into a solvent that is known as cryolite. Okay, if you want to know in detail, you boleh baca lah dekat internet pun. This is very common. Okay, so dia dissolvekan dalam solvent. So bila dissolve dalam solvent, we can still, this solution can still undergoes electrolysis. Dia still boleh di-electrolysekan. Okay, tapi dia kena dissolve dulu dalam solvent that is known as cryolite. So cryolite has the ability to dissolve bauxite, and at the same time it has lower melting point than bauxite. That's one good thing about cryolite ni lah. That's why we use cryolite as the solvent. Okay, alright. So now dia dah dissolve dalam solvent, dah become solution, and then we have mobile ion, kan? We can perform the electrolysis. So this is how it looks like. Okay, dia bukanlah macam electrolysis cell kita tu yang simple, ada electrode panjang-panjang, not necessarily macam tu. As long as we have energy to supply the current, and then we have cathode and anode. Okay, as you can see, the plate dekat yang apa nama tu, yang apa menyaluti casing ni is cathode. Sorry, is it? This positive is anode. Yeah, betul lah. Positive, yang positive is anode. So this is anode, yang positive is anode. Okay, we use graphite. Whereas negative ni is the cathode lah, kan? Cathode. Kenapa negative anodes? Oh, negative anode. Negative anodes. Positive anode. Betul ni, salah type ke apa ni? Okay, alright. So the electrode used is still graphite. We still use graphite. Okay, for anode and cathode. So itu dia punya tu. As long as we have anode and cathode, dia boleh di-electrolysekan. Okay, alright. So this is what happened at the cathode. Okay, cathode negative kan. So aluminium supply will be attracted to the cathode and will be discharged because we don't have any other species. Then apa nama tu, aluminium 3+. Cryolite is not involved. Okay, cryolite is not involved in the electrolysis. It's just as a solution. Kalau dia involved pun, it will not be selected as to be discharged at the anode and cathode. Okay, on the other hand, anode pula, oxide tadi will be discharged at the anode, will be oxidized. So it will produce oxygen. Oxide bukan water oxide. So they produce oxygen. Okay, they oxidize and produce oxygen. So this is the equation. Okay, so the oxygen react with carbon. Okay, bila oxide tu, okay, oxide, okay, you imagine oxide attracted to the anode. Okay, and then dia akan oxidize dekat anode. Bila oxidize dia jadi oxygen. Okay, one thing about oxygen ni, it has tendency to react with graphite. Graphite kan carbon. Okay, so this oxide will have tendency to react with carbon and produce carbon dioxide. Dia boleh pula react dengan carbon dioxide. So you can imagine, so after a while, okay, dia punya graphite tu it become thinner. Okay, sebab dia corrode because dia react with the oxygen to produce carbon dioxide. So lama-lama dia menipis lah. So after a certain time, a period of time, okay, the industry need to replace this graphite. Kena ganti dengan yang baru. So this is also another cost that you need to consider. Okay, alright. So when the battery is this is the story lah. Kat sini, yang tadi tu saya ceritakan. Okay, ini dia punya cerita pendek kat bawah. When the battery is turned on and electricity flows, the aluminium forms at the negative cathode and sink to the bottom of the tank where it is tapped off as a pure liquid metal. Okay, so aluminium will be attracted to the cathode. So dia akan attracted, so dia akan reduce into aluminium solid. So bila dia reduce, okay, dia akan jadi atom kan, so dia reduce jadi solid, dia jatuh dekat bawah ni. Okay, jatuh kat bawah ni. So dia ada inlet, outlet dekat luar ni. Nanti dia akan di-tap off, dia akan diasingkan dekat situ. As a pure liquid metal. So oxygen forms at the positive anodes. The oxygen react with the carbon of the graphite, forming carbon dioxide. Okay, macam nak alihkan ni. The positive anode therefore burns away and needs replacing regularly. I think other than cathode, it is also known as positive anode and positive anode and negative anodes. Okay, so kita kena replace regularly for the anodes. Right? So the application, this is economic consideration of aluminium extraction. Okay, electrolysis process is more cost effective than carbon reduction in extracting aluminium from bauxite. I think this is like the alternative to extract aluminium. Okay, but electrolysis is more cost effective. But still, extracting aluminium is expensive because it uses huge amount of electricity. So this is like alternative lah untuk extract aluminium. Okay, tapi still electrolysis is more cost effective. Energy and material costs in constantly replacing the anode. So nak replace the anode tu, it is costly. Okay, so it uses a lot of electricity and after a while, after a period of time, you have to replace the anode. So this replacement will be costly lah. Okay, so that is all. Okay, so all the checkpoint, okay, we cannot answer all the checkpoint now. Okay, so this will be your homework lah. Okay, so make sure that you complete all the checkpoint, then 10 to 15 minutes before we start our topic 5 next week. Okay, we will go through the checkpoint answer first. Make sure everybody do it. Okay, all right. Any questions so far before we end our session today?